Now, Parkinson's disease came to the attention of neurologists early, of course, because it's a movement disorder. It's something that's very visible, to others, and also, pretty clear to the individual who's suffering from the disorder as well. Symptoms of Parkinson's disease include a tremor, right? People get this sort of essential tremor. Bradykinesia means sort of slowness of movement. They have difficulty sort of moving in terms of carrying out movements. Also akinesia, which means no movement. Some of these individuals can actually become quite frozen in place, actually, depending on the amount of degeneration of the substantia nigra. So it turns out that the first line of treatment is generally a drug called L-DOPA. And I want you to think about where you've encountered L-DOPA before. Remember that dopamine is a neurotransmitter that is manufactured, like all neurotransmitters, from a very commonly available substance in the brain, right? And it turns out it comes from tyrosine, an amino acid, right? And the neurons in the substantia nigra, for example, also the VTA, that are going to release dopamine as their neurotransmitter, are going to manufacture synthesizing enzymes, right, that'll take the tyrosine and convert it into dopamine. Now, the neurons in the brain don't do this, but the ones that are going to release dopamine do. And remember that tyrosine doesn't go directly to dopamine, but there's an intermediate step. Tyrosine is converted into L-DOPA, which is then converted into dopamine by these synthesizing enzymes. So it turns out that you can't just give dopamine to patients, right, to alleviate their symptoms, because dopamine doesn't cross the blood-brain barrier, but L-DOPA does. So L-DOPA is administered. It gets taken up by a transporter, no doubt, into neurons, that the remaining neurons of the substantia nigra, right, that are still projecting into the basal ganglia, into the striatum, and you get an increase in the manufacture of dopamine. You're adding more raw material, basically, into these neurons, right? So the remaining cells tend to increase the amount of dopamine they release upon stimulation, upon the arrival of an action potential. And this seems to alleviate symptoms, at least for a period of time. So it turns out that as you continue to administer the L-DOPA, right, you will actually see changes in the postsynaptic membranes, right, in the basal ganglia. There's going to be receptor upregulation or downregulation. There's going to be changes in those postsynaptic membranes because you're changing the amount of dopamine that's being released, right? And so tolerance develops to the effects of L-DOPA. And patients require higher and higher doses of this drug, and then ultimately other symptoms begin to intrude, and the drug is no longer effective. So other strategies need to be found to deal with the symptoms of Parkinson's disease. So I want you to think about, I sort of just described these, but why does L-DOPA alleviate symptoms in the first place, right? Why not treat patients with dopamine, directly? And why doesn't L-DOPA actually work indefinitely? And why do you need to keep raising the dose of the drug?